All right, so getting ready for the Chapter 2 test here. My suggestion would be to go through the blank review first, and then watch this video, make sure you got everything correct. So first up, we got a graph x is greater than or equal to -3. So with the equal to, we're going to have the solid circle at -3. We're greater than or equal to, so it's everything to the right of -3. Again, we want all those positive numbers there that are greater than -3, and solid dot because of the equal to. For 2b, make sure you write this with the inequality on the left. So x is less than -1. Notice my inequality is still pointing at x there, still pointing at x right here. So it's going to be an empty circle at -1, and then everything to the left. All right, but again, always get the inequality on the left first. I think that makes a lot more sense. This one, again, would be written like this. X is less than 5. So next up here, number 3. Let me scooch this up. I'm using a new recording device here, so. All right, so for 3b then, write an inequality shown by the graph. Okay, so we're at 4, it's an empty circle, and we're to the right, so it's greater than. X is greater than 4. For number 4, define a variable and write an inequality for each situation. Graph the solution. She had less than $5. So let's just let M equal money. So she had less than $5, so M is less than 5. And at the bottom here, start to solve and graph these. So we have x minus 2 is greater than -1. I'm just going to add 2 to both sides. Oops. So x is greater than 1. That's what our graph's going to look like. All right, so next up here, the variables on the right, that's fine. We just gotta subtract 3 to start here with 6 is less than or equal to 3 plus x. So we end up with 3 is less than or equal to x. Just rewrite this with the variable on the left, so x is greater than or equal to 3. All right, next up then. Bill has a $75 gift card. He wants to buy jeans that cost $66, right? And solve an inequality to determine that additional amount Bill could spend without exceeding the gift card amount. So again, let's just let M be money again, since we're dealing with money here. All right, so we're trying to figure out how much money he has left. So he's got M plus the $66 for the jeans. And again, he's got this $75 gift card, so he has to be less than or equal to 75. Again, it can be equal to, that's totally fine. He's got a gift card for $75, so just can't go over that $75. So that's the inequality. Subtract 66 from both sides. We're going to get M is less than or equal to 9. So he can spend, what's this guy's name? Bill can spend at most $9. All right, so we got to solve one with an inequality with a fraction here. So we got 1/2 x is greater than -5. I'm going to multiply both sides by 2, the reciprocal of that coefficient. Again, I don't need to change anything here because I'm multiplying by a positive 2. So x is greater than -10. And there's the graph. All right, next up, we got to be careful here. We're dividing by -9, so we're going to have to flip the inequality here. Change it to a greater than. So x is greater than -8. Again, make sure you flip that inequality. All right, next up then. It says lip gloss costs $1.25 each. What are the possible numbers of lip gloss that can be purchased with 8? Okay, so let's just let G equal gloss right there. So we got 1.25 times G, and it's got to be with $8, so you got to be less than or equal to 8. You can go right up to 8, but it's got to be less than or equal to that. So we're going to divide both sides by 1.25. So we have 8 divided by 1.25, and it's 6.4. So we got to be less than or equal to 6.4. But again, these are whole numbers here. You can't go, lip gloss or like chapstick or something. You can't go to the store and be like, I'm buying like a half of one. So she can purchase up to She can purchase up to 6 lip glosses, so 6 or less. Again, I'm going to have it stop right here at 0 because you can't buy a negative amount of lip gloss, so that's the only reason for that. All right, so number 11, do distributive property. We get 5x plus 5 is less than 35. So we're going to subtract 5 from both sides. I get 5x is less than 30, divide both sides by 5, and I get x is less than 6. All right, so number 12. Rich has a goal of saving more than $1,500. He has $400 saved now, and each month he adds $50 to that amount. The inequality 50M plus 400 is greater than 1,500 can be solved to find the number of months it will take Rich to reach his goal. How many months will it take to Rich to reach his goal? So let's solve this. 50M plus 400 is greater than 1,500. I'm going to subtract 400 from both sides. Divide both sides by 50, and I get M is greater than 22. So just one thing you got to do here then, though, is he wants to save more than $1,500. At 22 months, he's going to have exactly $1,500. So in 23 months, he will have more than $1,500. So we have 4x plus 6 is less than or equal to 2x plus 12. So we'll get 2x is less than or equal to 6. Divide both sides by 2. X is less than or equal to 3. All right, so next up here we got a variable on both sides of the inequality. I'm going to subtract 2x from both sides. I just like to get the variables on the left, but be careful. That's a negative 3x there. So I'm going to have 4 minus 5x is less than or equal to negative 6, then subtract 4 from both sides. So negative 5x is less than or equal to negative 10. Then when we divide both sides by negative 5, make sure you flip this. We should get x is greater than or equal to 2. Next up, with these compound inequalities, we got to subtract 3 from the left, the middle, and the right. Then divide everything by 4. So that'll be negative 1.5 less than or equal to x less than 3. So negative 1.5 is going to be right there. And then 3 we got right there. They're done. All right, just don't forget, you got the left, the middle, and the right on those and inequalities. I got an OR inequality here. So first up, I'm going to add 5 to the left and the right there. So I got 3x is less than 6. Divide both sides by 3. X is less than 2. Or add 18 to both sides. So I got 9x is greater than or equal to 27. Divide both sides by 9. I got x is greater than or equal to 3. All right, next up. So one day at band camp, the high temperature was 84 degrees Fahrenheit and the low temperature was 66 degrees Fahrenheit. Write a compound inequality to represent the day's temperature. So let's just let T equal temperature. So the low was 66, the high was 84. That's all you got to do. We're between 66 and 84. All right, so 18 then, we got absolute value of 2x plus 4 is greater than 6. So it's greater than, so it's going to be an OR inequality. So we're going to have 2x plus 4 is less than negative 6, or 2x plus 4 is greater than positive 6. Again, this is the tricky one, but remember, 2x plus 4 being more than 6 units from 0. To the left, more than 6 units to the left is like negative 7, negative 8, negative 9, negative 10. All those numbers are less than negative 6. So that's what you have to set up there. So I'm going to subtract 4 from both sides. I get 2x is less than negative 10. So x is less than negative 5. Or 2x is greater than 2. X is greater than 1. All right, and last problem then. Actually, we got 2 more. So I got the absolute. First up, I got to isolate the absolute value. So you can't, when you go to decide between this being an AND inequality versus being an OR inequality, it's got to be just the absolute value on the left side of the inequality. So that's why I subtracted 3 to start. Now I can decide it's a less than or equal to. So it's going to be an AND inequality. And then I just got to add 2 to the left, the middle, and the right. So we get negative 3. All right, so last up, Tom is going to solve the inequality below, and the inequality x represents the length of a rectangle. So solve the inequality in sheet work. So it's greater than, so this is going to be an OR inequality. So we're going to have 6 minus 4x is less than or equal to negative 10, or 6 minus 4x is greater than or equal to positive 10. So that means we'll get negative 4x is less than or equal to negative 16. So x is greater than or equal to 4 then. I divide both sides by negative 4, and I flip that inequality. Over here, I got to subtract 6 from both sides, so we get negative 4x is greater than or equal to 4. And then I divide both sides by negative 4, so I get x is less than or equal to negative 1. Flip it around so you get both those. Now, remember what we were saying here, though. X represents the length of a rectangle. The length of a rectangle cannot be negative, so get rid of that. So x is just greater than or equal to 4. So negative 2, in this one says Tom says x equals negative 2 is a reasonable solution. Explain why Tom thinks that, but also explain why he's incorrect in this situation. All right, negative 2 satisfies x is less than or equal to negative 1. But since x represents length of a rectangle, and length cannot be negative, x equals -2 is not a solution. All right, so that's it. If you're good on these problems, you'll be good to go for the test.